day everyone, I'm GRP Valdivieso. Today we're going to explore one of the most fundamental data structures in computer science, linked list. So linked list. What is linked list? A linear data structures where elements are stored in nodes. Each node contains data pointer to the next node. Unlike arrays, elements are not stored in contiguous memory. So, what is a linked list? A linked list is a type of linear data structures, but unlike an array, its elements are not stored in one continuous block of memory. So, instead, a linked list is made up of individual nodes. Each node has two parts. So, na siya data and actual value. The nodes is storing pointer to the next node. This tells the programs where the next node is located in memory. Because of this pointer system, the nodes can be scattered anywhere in memory. So, what keeps them connected? It's the change of pointer from the nodes to the next. This structure gives linked lists a lot of flexibility compared to array. So, why use linked list? Why use linked list? So, dynamic size grows, shrinks at runtime. Efficient insertion, deletion, no shifting elements used for implementing stack, queues, graph, adjacency list, memory management system. So, linked lists have several advantages that makes them used in many applications. Dynamic size linked lists can grow or shrink at runtime. You don't have to decide the size ahead of the time like with arrays. Efficiently insertion and deletions. So, when you insertion or delete an element in an array, many elements might need to be shifted. In a linked list, you just change a couple of pointer, making this operation very fast. So, common uses linked lists from the foundation for many other data structures such as stack, queues, graph, adjacent list. So, memory management system, these structures rely on fast insertion, deletion, and flexible memory usage, which linked lists provide. So, example of C or C++ style. So, data, next pointer to another node. And this is the picture of it. So, to understand what a node looks like in a code, think of a simple structures in C or C++. So, a node usually contains a field for data or pointer to the next node. This is typically defined using a structure when several of these nodes are linked through their pointers. They form the entire linked list. They form the entire linked list. So, singly linked list. So, singly linked list. A singly linked list, each node points to only the next node. So, last node point to null. Simple structures efficient for forwards traversal. So, diagram, next, data, next, into the data, next, until the data null. So, a singly linked list is the simplest form of a linked list. So, each node has one pointer and it points only to the next node in the sequence. So, the last nodes in the list point to null to indicate the end. So, this structure is straightforward and efficient for forward traversal, meaning we can easily move from the first node to the last by following the pointers. So, the diagram would look like this. data next or data next until the data null. So let's proceed to the doubly linked list. So each node has two pointer, next or and previous. So allow bidirectional traversal requires extra memory, diagram, null, perv data next into perv data next into null. This is like exactly you see it. So doubly linked list is a doubly linked list builds on the idea of the singly linked list but adds another pointer. Each node contains two pointer, next node pointing to the next, previous node is pointing to the previous node. So this allows the bidirectional traversal, meaning we can move both forwards and backwards through the list. So however, because each node needs an extra pointer, it means more memory. So the structure looks like this. It looks like this in the PowerPoint. Looks like that this. So circular next is the circular linked list. So last node points back to the first node. No null termination used in scheduling applications or round robin. So the circular linked list, in a circular linked list, the last node does not point to null. Instead, it points back to the first node, forming a circle. So this eliminates the concept of a list ending, which can be very useful in scenario where you need continuous cycling, such as in CPU scheduling or algorithms like round robin, where the process cycle repeats over and over. So let's proceed to the basics operation. So common of operations: traversal, insertion at beginning, at the end, specific index, and deletion, and search. So finally, linked list supports several important operations. So traversal, visiting each node one by one to read or process its data. So insertion, adding a new node at the beginning where we adjust the head pointer, at the end where we modify the last node's pointer, at a specific index where we insert the node in the middle by adjusting the pointer correctly. So deletion, removing nodes from any pointer by reconnecting the surrounding nodes. So the search is going through the nodes to find a particular value. These operations were fundamentals to work with linked lists and show how flexible the structures for dynamic data handling. So that's all. Thank you for watching.